Hi, here we go with the first section of the year. One of the big focuses of PreCalc is that there is an SAT component to the class. And so each of these words here are things that could show up in an SAT question. So we are going to just define what each of those are. Integer is the number that you should probably be really familiar with. That just means that it is a non-decimal number. Fractions can get tricky, but essentially you're looking for a number that is like 1, 2, 3, 4, 5, 0, -1, -2, -3, and so on. So if I look at all of these, 6 is an integer, it's a nice number like that. We'll see if any of these along the way fit that. Whole number often gets confused for what integer means. A whole number is really any positive integer or 0. So 0, 1, 2, 3, 4, 5, all of those are whole numbers. Natural numbers, really close to it as well. They are positive integers. So that just means that it's everything that's like a whole number, just not 0. Rational and irrational, really important distinction there. Irrational numbers are non-terminating, meaning they don't have a stop, they go on forever, and they are non-repeating. So, something like -2/3, we know that that's 0.6666666, but negative, that is not irrational because it is a repeating 6 over and over and over again. Rational numbers, they are going to kind of just be anything that we know all the digits to, or it is predictable. So we know all the digits, or all the digits are predictable. And then real numbers are really just everything we know. As long as it's not an imaginary number, we know it is a real number. So let's take something like -2/3. Is it an integer? No. Is it a whole number? No. Is it an integer? No. But it is rational because all of those digits are predictable. So it can't be irrational then, and it's real because it's not imaginary. Pi, 3.1415926, so on and so forth. Not nice rounded numbers with just one digit, and it goes on forever and ever and ever in an unpredictable way, so it is irrational. It's not imaginary, so it's real. Square root of -49. Well, we know the square root of 49 to be 7, and there's that negative outside. So we know it to be -7. -7, now we've got that kind of nice one digit. That makes it an integer, but because it's negative, it's not going to count as either one of these. It is rational. We know all the digits, and it's real. It's not imaginary. Cubed root of -8, but a negative again out front. Cube root of -8, we got to think what number times itself 3 times is -8. Well, that's -2. But -2 becomes a +2. So +2, it is a positive integer. It is a positive integer or 0, counting for both here. We already called it an integer. It is rational. We have all the digits. And it is real. Square root of -9. Well, we know the square root of 9 to be 3, but this is where the imaginary part comes in. The square root of a negative is I. So we can't label any of these things because it's an imaginary number. It's actually not a real number. That's a mistake because it's not imaginary. So this actually gets none of the categories. Imaginary numbers don't count. You'll notice in the notes too sometimes that you've got different page numbers that are going to coordinate to different things. This just wanted you to look at some words, not a big deal. We'll skip that in the video. But let's place two rational and one irrational number between, we'll just do the numbers 1 and 2. So if I'm trying to think two rational numbers, well, rationals could be whole numbers. Any whole number between 1 and 2? No. But I have to know all the digits for it to be rational. So maybe 1.5. Or maybe I want to express it as a fraction, 3/2. Those are options. There's an infinite amount of options here. Between 1 and 2, there are an infinite amount of numbers. There's so many decimal places that could be here. So let's pick a different one, maybe 1.1. All right, works. Then we got to think irrational. It's got to go on forever and ever and ever. Kind of like pi. How about pi over 2? If I do pi over 2, think back, you heard this in your trig days. It was about 1.57. And it goes on forever and ever and ever. That makes it irrational. But pi over 2 is a nice way to capture it all. Or maybe square roots. That's another way. So the square root of 2 here, that is 1.41 ... Again, goes on forever and ever, but in a different way. It looks like we know them all. So knowing rational versus irrational will be helpful. Here, this again just makes you want to look at the book a little bit. It's just saying that interpreting inequalities, if we know that 3 is less than 4, then the book would tell you to fill in some blanks and see that 3 minus 4 is negative. That this has to be smaller than the right side. So since the right side's bigger, if you were to put a subtraction sign here instead, it would be negative. These two things are nice. They're really just helpful for the SAT. For your first quiz of the year, you're going to want to make sure that the rest of this video is what you're paying attention to a whole lot more. So inequalities. You made number lines of these before, open, closed circles. We're just going to review that a little bit. So 2 and 5, those are on the ends. Those are important numbers. Let's see how we've got to put some circles and some arrows. So if I cover this up and I just have x is less than 5, I got to think, what numbers are less than 5? Things like 1, 2, 3, 4. Those are all things to the left. And less than requires an open circle. Open circle says I don't want that specific number. 5 is not less than 5. So because I want to get really close to it but not exact, open circle. That means with 2, I'm going to want a closed circle. I can have on this side 2 being less than or equal to x. Meaning since it could be equal to 2, we want the closed dot. Then let's cover this up and think what could count. Well, 2 is less than or equal to numbers like 3, 4, 5, so on. 2 is less than 3, 4, 5, could be equal, but that just means we're going to the right. Notice how these are pointing in on each other. That means the middle here we want as a part of the overlap. That this is going to make things fit, that if I put 3 or 4 or pi in the middle here, it would fit both sides. Something like C, a little bit more what you're familiar with. You're used to putting just the 1 down. We say, line underneath, or equal to, closed circle, but it's greater than 1. So what's greater than 1? 2, 3, 4, we're off to the right. So this is what you've been used to. This is what we'll deal with quite a bit here in PreCalc. So knowing how to do the double ones is going to become important. Let's take a look at this though. -2 is on the left and -4 is on the right. It's kind of a problem because -4 is the smaller number. It comes first on the number line before -2. So make sure you're checking both of these. But let's see. No lines underneath. I'm going to bet open circles. We just now have to check directions. Cover it up. X is greater than -4. Bigger than -4. Remember that negatives are tricky and are almost the opposite. So numbers that are bigger than -4 are off to the right. Sometimes using 0 as a benchmark to help will be good. So is 0 greater than -4? It is. So we would shade towards 0. Then let's think. -2 here, greater than x. What things need to be, because where -2 is bigger than it? Well, -2 is bigger than the numbers off to the left. It's bigger than -4, so we know we've got to push the arrow towards -4. Again, we're seeing it line up here in the middle. Why do we do these? Because we're going to deal a lot with these things called intervals in the first semester of pre-calc, where we're going to have a range of things going on. It's going to have a starting point and a stopping point. And we're going to be interested in what's happening between those points, or say, this is the range where these things are happening. Notice here too how these three inequalities are the same as these three inequalities. With that, that means you are going to sometimes in pre-calc, oftentimes see in the notes that we're going to do some things with the same examples and just kind of keep pushing those through and figuring out more and more about it. So now we want to write the inequalities as an interval. Well, interval notation says take your starting point and your stopping point and separate them by commas. So we see the start, we see the stop, putting those two numbers separated by commas. Then interval notation says you need to use brackets if you've got a closed circle or the line underneath, but no line underneath or an open circle means the parentheses. We want to know if these numbers on the edge are included or not. So the bracket means included. It's a part of what makes it true. It is true that 2 is less than or equal to 2 if we were to plug in 2 for x. So that's why we want to include it. Bracket. Where 5, we get the parenthesis because it doesn't make sense. 5 is not less than 5 if we were to plug it in for x. So here, we want to do the starting and stopping point from left to right on a number line. So we're going to have -4, comma, -2. Again, the start and stop point. Because you've got the open circle here on both sides, we want the parentheses. Here, we have a starting point. From left to right, I see where it starts. I see it's starting at 1. But the problem is it's going all the way to the right. So we got to think what's happening all the way at the right on a number line. It just gets infinitely large. So that becomes the endpoint. So closed circle, we know bracket, but infinity, we've got to think about that. Can we actually ever equal infinity? Can we ever officially reach infinity? The answer is no. So because we can't ever exactly reach infinity, there is that next number, even though we think we reach the end, parenthesis. Infinities always get parentheses. Here's a new one. I want you to just take a second, maybe pause the video, try that out on your own. All right, after having paused the video, you would have had -4 and 0 as your starting and stopping points. And because you've got the lines underneath both, brackets for both. That's how hard it's supposed to be. Now here we're going to think about different ways. Maybe you start with the interval notation and now we want the number line or we want the inequality. So let's figure it out. 1 and 3. Starting point, stopping point, bracket. What do brackets mean? Means closed circle. Parenthesis means open circle. And intervals always mean we've got the stuff in between. So there's our number line. We also know that 1 and 3 are important for the inequality. We're going to put x in the middle. We just got to figure out which inequality symbols make sense. So a number in the middle here is 2. So we're going to pretend that x is 2. Well, 1 is less than 2, and 2 is less than 3. So plug in a test number to see what might work for you. The last thing is for bounded or unbounded. We're going to talk a little bit later in the semester more about what bounded means and what its really technical definition is. Right now, I want you to think, does it have boundaries that are clear and established, or does it not have some boundaries? Something like this is bounded. It starts, it stops at a very specific spot. We know where it goes. So this is bounded. But if I look up here, that arrow going all the way over is going to indicate unbounded because it doesn't have an official stopping point. So if there is no official starting point or stopping point, unbounded. Take another second to fill this in on your own. Pause the video. All right, hopefully you got these answers. Double check if this is not what you got. I would like you to come find me and ask a question. But take a look at this. Now that you see the answer, if you were off, maybe pause the video. See if you could figure out where you went wrong. Stuff like this I want you to be comfortable with for the quiz. All right, let's go to the back side. Other couple big things you'll need this year for pre-calc. The distributive property, for example, knowing that a number out in front of the parentheses distributes to both things inside. So negative 3 times x, negative 3x. Negative 3 times negative y becomes a positive 3y. Factoring, on the other hand, is undistributing, that we're going to figure out what's common. What number goes into both 2 and 4? Well, that's 2. What goes in, or how many x's do x to the third and x squared have in common? They have 2 in common. So that becomes our greatest common factor. Then we got to think about what's left over. So if I divide out a 2 and take out 2 x's, I only have 1 x left. Then, if I divide out a 2 from the positive 4, I get a positive 2, and I took all 2 x's away. So I have no more x's left. Both of these things are things that we're going to need to make sure you know how to do the whole year. That's why we're doing it from day one. But these kind of properties, to distribute and to undistribute, they combine addition and multiplication. So this distributive property does both. The last thing we'll need to think about is properties of exponents. It's come up since middle school in Algebra 1, Geometry, Algebra 2, stuff you just got to know at this point. So there are 1, 2, 3, 4, 5, 6 different x's. If you add them together, you should get 6x. So repeated addition we call multiplication. But on the other hand, if you multiply a lot, and there's 6 of them again, you'll get x to the 6th power. Repeated multiplication is exponential. Or sometimes you could say the powers. So we're just going to review some of the basic rules of exponents. Anything to the 0 power. You see anything any number, a being any number, and you raise it to the 0 power, it equals 1. So if I raise 2 to the 0 power, 1. Negative 3, all in parentheses, to the 0 power, 1. 2.5 to the 0 power, even though it's a decimal, still 1. 1/4, all the way raised to the 0 power, still 1. Fraction doesn't change anything. This one, though, let's think about it. You might think, oh, still 1. Negative 2 to the 0 power, 1. But another way to write what's going on here is negative 1 times 2 to the 0 power. See how these are different? One has parentheses, one does not. That's how we know which way it means. Then if we think about order of operations, your order of operations say exponents come first. So this 2 to the 0 comes first, simplifies it to a 1. Then you've got negative 1 times 1, making the whole thing negative 1. All right. Negative exponent property. See how there's some no fractions to fractions. Some of you might remember that it flips things or moves it. And the negative exponent rule really does just switch what side of the fraction it's on. So here I've got a 7 to the 0 power. It's 1. A to the negative 3, though, it's got to get bumped down to the denominator. It did not exist, but now it does because of the negative exponent, turns it positive because it moved. Mathematicians hate negative exponents. Make sure you get them out of there. And then this b stays the same. So you got a 1b on top and an a to the third on the bottom. You could simplify that to just b over a to the third. Over here, we've got now a negative exponent outside some parentheses. So it distributes just like other numbers outside the parentheses do. So here, I've got x to the negative 1 power and 4 to the negative 1 power. Now everything here has a negative exponent, so that means it's going to switch. And exponents of positive 1, we don't care about, so we know we're done. It's optional to have written that. So those are a couple negative exponent ones. If you need more help with that, let me know, but we'll skip those other two examples. Next part down here says make sure you know how to distinguish a couple things. If I've got x squared times x to the third, two like bases being multiplied, their exponents add. So I get x to the 2 plus 3 or x to the positive 5 power. But if it's an exponent raised to another exponent, that becomes multiplying. So that's going to become x to the 6th. It's going to become important that you know how to distinguish the two. Also, if you've got regular numbers as bases, it works the same. So this will become 3 to the 5th power. And you could figure out what 3 to the 5th power is, but that's okay. We'll leave it as that right now. We're focusing on the properties. Down here, we say, is anything different? Because you got a fraction. There's one thing you got to remember. Fractions get paired with subtraction. So when you're dividing exponents, it's subtraction. So I would subtract the 6 and the 2 right here. 6 up top, 2 down below. I've got 6 and I got to take away 2. P to the 4th power. Again, over here, we would see some distributing. So here with this, we'll get x to the negative 4th power. Power to another power means multiply. We've got 4 to the negative 2 power and y to the negative 2 power. They're all negative. Everything switches. So 4 squared y squared x to the 4th. 4 squared we know to be 16, so that's a simple one that we could simplify. You'll also notice at the bottom of every homework assignment there will be some things posted here. So the homework assignment for this is on pages 11 through 13, 7 to 43 odd, and 47 to 51 all. So make sure you take care of those. I know this video was a little long. Hopefully they won't be all like this.